Hello there, AQR students. We're beginning our last bit here. And so we're on SAS Student Activity Sheet 6, Investing as you go. So now we're looking at annuities. An annuity is a financial product that accepts and grows funds and then, upon annuitization, pays out regular payments to the investor. Annuities are often used as retirement funds. Some annuities are funded with a lump sum investment, while others are funded with an initial investment and additional regular deposits before retirement. What complicates the time value of money, TVM, of an annuity that you pay into is that the investment increases in value due to both compound interest and increasing principal. So we've been looking at the situation where we just take a lump sum, we sit it down, and we leave it alone for some period of time, whether it's 5 years, 10 years, or 50 years. And it grows over time because of the interest that it's accruing. Okay? Now what we're going to do is we're going to have some amount of money that we start with, or maybe we don't start with any money, but we put in a regular amount of money. All right? We're going to put in payments. So look at this first example here. The following graph shows the value of a lump sum investment of $1,000 earning 10% compounded per year. So that's this row of dots on top. All right, we start with $1,000 and then it gets 10% interest per year for 5 years. So that at the end of the 5th year here, we're making it's worth $1,611. All right, versus an annuity with an initial investment of $200. We're starting this one with the diamonds on the bottom part. We start with $200 and it earns 10% compounded per year with additional $200 deposits made each year. So $200 at the end of the year, it's made 10%, $220. At that point, we add in another $200, so now it's $420. At the end of the year, it's $462. We add in $200, that's $662. We put in interest, that gives us up to $728. Add in $200, $928. Put in interest, $1,021. Add in $200, that's $1,221. And then it gets interest up to $1,343. So clearly it does not reach the amount that the $1,000 we had got to. Now the reason for that is that with the first investment, that $1,000 got 10% interest every year. Whereas in this other, although we put in the same amount, we also put in $1,000, it's that only $200 got 5 years worth of interest. And then another $200 got 4 years worth of interest, a third $200 got 3 years, and then one $200 got 2 years, and then the last $200 only got 1 year of interest. Whereas all the $1,000 gets 5 years of interest here. So we're losing out on interest, but you can see that if we kept on adding $200 per year, this thing in the next year or two, it's going to pass up. It will pass up this $1,000 that we started with. Okay? So number one at the bottom of the page, how is the process different for calculating the future value of each investment? Well, it's just interest. So for the first investment, we're adding interest every year. That's all we do. For the second investment, the one where we're not only adding interest and a $200 deposit every year. Okay, and this is more likely the way most people save money. We've been talking about these people who want to retire with $1 million or whatever, and they need like $100,000 or $200,000 or something right now so that they can have $1 million when they retire in 40 or 50 years. And most people don't have an extra $100,000 or $200,000 lying around. So instead, what people do is they set aside some amount of money per month or per quarter or per year. They put in an amount of money, and that money then accrues interest over time, and every year they put aside that money and it grows and the interest grows on it, and that's the way you save money for retirement. That's the smart way to save money for retirement. You just set that aside, don't even consider it, and it makes money, and you have it then. The sooner you start saving, the more it's going to be worth when you're ready to use it. Okay? All right, number two. Refer to the future value formula in student activity sheet 3. How is the process different in calculating the future value of an annuity when compared to using the future value formula? All right, the future value formula said the future value equals the present value times 1 plus r over n to the nt power, where r is your interest rate, n is the number of compoundings per year, t is the number of years, present value for PV, future value for FV. Okay? So this works fine. If we wanted to figure out, you know, for the $1,000, this will work great because we can put in 1,000 here times 1 plus 10% over once a year to the 5th power. 1 times 5 would be to the 5th power, and that works great, okay? So the problem is if we're putting in $200 per year, well, we have $200 right now. That's our present value, which is going to get 5 years of interest. Then we have another $200, which is going to get 4 years of interest. And then we have another $200, which gets 3 years of interest. We have $200, which gets 2 years of interest, and then $200, which gets 1 year of interest. And so we'd have like 5 different formulas here, and we would have to add all those together in order to get our answer. And that can get, you know, for 5 years, it's not that bad. But let's say we were doing this for 5 years and adding in monthly. Then we'd be talking about 12 times 5, 60 different formulas. No one wants to mess with that, all right? So there's got to be an easier way, okay? So let's look at number 3. An annuity can be thought of as a series of values connected by a common ratio. What common ratio connects the values of the annuity over time, shown in the graph at the beginning of this activity sheet, and how is the ratio related to the problem situation? All right, so if I think about, you know, what I was just saying, that first $200 would be $200 times 1 plus the 10%, we're only compounding once a year, to the 5th power, right? And then the next one, and we can get some kind of answer for that. Then the next one is going to be 200 times 1 plus 10% over 1 to the 4th power. And then the next one's going to be 200 times 1 plus 10% to the 3rd power. And so always this number in the parentheses here is going to be 1.10. All right? And that, how is that ratio? This is our ratio. All of them have that 1.10 ratio. How is that ratio related to the problem situation? Well, this is 1 plus our interest rate, 1 plus r, where r equals 10%. Our interest rate was 10%, and we add 1 to that, and so 1.1. Okay? All right. We're going to skip over number 4. We're going to go straight to number 5. Number 5 says, in student activity sheet 5, you learn to use a TVM calculator to determine different variables related to TVM, the time value of money. Now, we were using the website grunderware.com to do our TVM calculations. And Grunderware is wonderful for what we've done in the past, but it's not going to work very well today. In your prior work with the TVM calculator, you only considered lump sum investments, and the payment variable was always 0, and that's why Grunderware was great. But Grunderware doesn't handle payments. Okay, so we got to try something else. So it says, explore using the TVM calculator to determine the future value of the $200 annuity over 5 years. Compare your answer with the known future value of $1,343.12. List the values you assign to each variable and explain why. Note, interest is typically paid at the end of the compounding period. In this case, you make payments at the beginning of each period. Therefore, you must change appropriate variable from end to begin. Okay, so here's how we're going to start. First of all, probably the easiest thing to do is to Google TVM calculator. If you do that, then we're going to use the very first choice. The first choice, at least when I did it, was fncalculator.com/financial calculator, # type equals TVM calculator. Okay, and I'll show you that right here. Okay, so here is my Google search, TVM calculator, and here's my first thing, TVM calculator, financial calculators, fncalculator.com. And it takes us to this website, financial calculators, TVM calculator. So this is what we're going to use. I think this will work out pretty well for us. If I need to change it, I think it'll be fine for this lesson. If I need to change it in a future lesson, I'll let you know. All right? Okay, so we need to fill in everything here. And so let's go back to our table over here and let's fill in our stuff on the table and then we'll fill it in on the website, and then we'll be in good shape. Now, the number of compounding periods, this is a little different. On the Grunderware, it asks for the number of years, but here it's number of compounding periods, which, we're only going to have, in this case, we're only doing once a year, all right? One payment per year, one compounding period per year. So it's going to be 5 years, one time a year times 5 years, and so our end value is going to be 5. We're talking about a 10% annual interest rate. Our present principal or present value, we're going to start at 0. Payment, we're going to put in $200 for our payment, and what we're looking for is the future value. Okay, so there's everything we need. So now I'm going to come over here and I'm going to put those things in to our website. So our present value, we're going to put in 0. Our payments, we're going to put in $200. Don't know the future value, we're going to figure that out. This is 10%. Notice our payment's going to happen at the beginning of the period. I forgot about that, so be sure you hit that button to change it to the beginning of the period. We have 5 periods. Remember, once a year. Make this annually, once a year for 5 years. 1 times 5, it's going to be 5 periods we're going to have. And so we want to solve for the future value here. So if I click on the future FV, well, there we go. All right, notice it gave us a negative number, negative $1,343.12, which is a little weird. So here's the way I think about this. The 200, and these numbers will always be opposite signs because, well, I shouldn't say it, but usually will be opposite signs. So this is like I'm putting $200 in, and then I can take $1,343.12 out. All right? So I'm doing opposite things. One of them, the payment in this case, I'm putting in. Future value, I'm taking out. We'll have other times when, if the present value we're adding to it, we want the present value. If I start with $200 and I'm adding $200 on every time, I would want those to be the same sign. But this would also work like if I had a loan. Let's say I had a $10,000 loan, then I would make negative payments there. If I had positive $10,000 here, then I would put a negative $200 to drain off that loan so that they'd be opposite signs. But we'll talk more about that as we go along. But anyway, you can see this number, $1,343.12, is exactly the number that they got when we did the formulas here. It's the $1,343.12 here. Okay? So our answer is 1343 and 12. All right. I think that's enough for this lesson. I'll make a second video where we'll go through the rest of this lesson and post it for Thursday. Hope y'all are doing good. Bye-bye.